A little late. That was a little late, John.
I sent you a message in the chat too.
Oh, yeah, I don't look at the chats. No, I should. I do occasionally. It's hard enough to keep the focus on everybody here. So what I'm going to do right now is I'm going to pin myself, which means you'll just be seeing me for a while. And you can have a gallery view up in the corner. Okay, so hey, it's Saturday morning. It's raining a little bit. It's colder than all get out. I'm not racing off to the golf course today. No, that was a nightmare last week. You know, being up so early and then getting prepped and doing this thing here and then racing the Sandpiper and then walking 7 miles at Sandpiper, although it was an incredible day. So I'm going to try to not do that for a while, at least till next Sunday. But in the meantime, I've made some videos yesterday of some really interesting sites. So we can talk about foundations and concrete and CMU with some examples. In the meantime, Jim had mentioned to me that when he was going through Wednesday night, when he was going through the 9 and 10, chapters 9 and 10 with you, that there was some confusion, or there were some people that weren't super clear or were confused, rather, that's what he said, on figuring the volume of concrete. So I'm going to do just a simple illustration here on how to figure the volume of concrete. And who wants to unmute themselves and tell me how is concrete figured and what's it figured in? What unit of measurement?
Cubic unit, right?
What was
Cubic
it?
yard.
Yeah, cubic yards. Cubic yards. So this is a typical footing right here, and it's actually only typical for around here because it's so darn deep. But slab on grade, so there are varieties of ways to use concrete in the building. Two main ones around here. The first one would be slab on grade, which is the most economical and the easiest to do. And the next is a raised foundation, which is both have footings. Raised foundation has raised poured in place stem walls, and then the floor, wood floor, usually could be metal, is laid on top of that raised foundation. So there's a crawl space of a minimum of 18 inches underneath. But in figuring the concrete for this slab, 14 by 28, and for the footing, well, let's figure out, because it's going to be a monolithic pour. So this will be dug out of the dirt. This guy. And then this will be formed with form boards. And you'll see, not just an illustration on the board, you'll see stuff from the videos I'm going to show you of typical forms and footing trenches. But just figuring the concrete. First thing we need to do is we need to start it in feet. Let's dispense with inches. So if you have inches, convert them to feet. In other words, if you have a thing that's 20 foot 6 inches, it's 20 foot 0.5 feet. If it's 20 foot 8 inches, it's 20 foot 0.67 feet. And we can talk about converting to decimals later. But in the meantime, let's figure the easy part, and that's our slab, right? So we take a slab that's 28 by 14. Let's get the area of the slab. So 14 times 28. And hey, Katie and Lindsay, can you see the board now? Because you had said that it was a little hard to see the board before. Is that better?
Yeah, Lindsay, it's pretty hard to see, at least for me. I'm not sure.
It a little closer would be better. It sure is better than last week.
Okay, good.
So yes,
okay.
that's a bit better. It's fuzzy for us, but
okay, so go ahead.
Hugo's making comment that it might be also a little awkward for him. He's trying to watch the Zoom box where the interpreter is, as well as the presentation box. So he's also going back and forth. You might just want to just add just a teeny bit of pause so that he has a chance to hear the comment and then look.
Okay.
That might work.
Okay. So we're going to take the slab, right? 4-inch thick slab. 14 by 28 feet. So let's go 14 by 28. We'll get the area of the slab. 4 times 8 is 32. 2 is 11. 0, 280, 293. So 392 square feet is the area of the slab. The slab is 4 inches thick. 4 inches is a third of a foot. So a third of 392, right? We're going to divide it by 3. And let's do it up here. So I've got a little room. 3 into 392. This 1 is 3. So it's 13 and 2/3, right? No. So I'm sorry. 2 goes 0, 130. Yeah. So it's 130.67. That's what it is. But for purposes of this argument, we're going to call it 130. Right? 130 cubic feet. Okay. So that's the area, 14 times 28, which is 392, times 0.333, or divided by a third, because it's 4 inches thick. So it's 130. Rounded down slightly, very slightly, cubic feet. So square feet, right? 390 square feet times the thickness is going to give you the cubic feet, not just the one plane, but the next plane is the depth of it that gives you cubic feet. So 130 cubic feet, right? That's for the slab. Now let's go over and get the footing, because it's a perimeter footing, and we're going to have to do 2, right? Because they're shaped differently. The stem wall is one thing, and the footing is another. And I've drawn the footing 30 inches deep, which is really deep for a footing. But in Santa Barbara County, if you haven't had a soils report, if you haven't had an engineer look at a soils report and come up with how deep your footing needs to be based on your particular soil, then if you go 30 inches deep, you don't need a soils report. They figure it's deep enough, even if you haven't hit undisturbed mineral soil, you should have, and it's going to be deep enough. So this thing is going to be 30 by 18. So in a cross section of that, right, 30 by 18 is 30 times 18. 30 times 18. 0, 4, 2, 540, right? Yeah. Yeah, so that's 540. That's square inches. So you know what? I'm sorry, I did tell you not to use square inches. We could keep going in square inches, but let's do this in square feet, right? So 30 inches is 2.5 square feet, and 18 inches is 1.5 square feet. Hopefully you all see that, right? 30 inches, 12 inches to a foot, 12 goes into 30, 2.5 times. 18, 12 inches to a foot, 12 goes into 18, 1.5 times. So let's just take and stop doing this longhand and pretend that I'm actually in the 21st century and take a calculator and go 1.5 times 2.5 equals. So 3.75. So 3.75 is the square area of a cross section of the footing. Now to get the cubic feet of it, we need to take the whole length of it. So it's 28 and 28, that's 56. 14 and 14 is 28. So 28 and 56 is 84. So we need to do 3.75 times 84 feet. That's square feet times 84 lineal feet. Times 84 equals 315. Okay. So that's 315 cubic feet. Now let's do the stem wall. Stem wall is pretty easy. Again, it's going to be 84 feet again. It's going to be the same amount of lineal feet because it's the same pad, same same slab that we're talking about, same footing that we're talking about. Only this guy in the cross section for the area is 6, which is 0.5 of a foot, and 24 inches, which is 2 feet. So 2 times 0.5 is 1. So a half of 2 feet is 1 foot. So it's a cubic foot for every lineal feet of this guy. And there's 84 lineal feet. So it's another 84 cubic feet. So now we've got the 3 numbers. We've got the cubic feet in the slab, the 4-inch slab that's 392 square feet big. And then we've got the cubic feet of the footing, which is 1.6 by 2.5 feet deep. And then we've got the cubic feet of the stem wall, the 2-foot stem wall that's 6 inches that the plate will sit on once it's all poured, and the house will be built up from that. So these three things are the cubic feet. So let's add them up. 9, 2, and 5. 529 cubic feet. Now we need cubic yards, because concrete is sold in cubic yards. So can somebody unmute themselves and tell me how many cubic yards, how many cubic feet in a cubic yard?
27.
Thank you. Who is that?
Dennis.
Darren? Way to go. All right. So 529 divided by 27 equals 19.59. Let's round up to 20, but it's 19.59. So 19.59 equals 20 yards, 20 cubic yards. And when you yards, and when you talk about yards, a yard's basically a cubic yard. You don't talk about square yards really. I think about you could. So, but concrete is figured in yards, which is a cubic measurement, and there's 20 cubic yards here. A full concrete truck is about 10 yards. Full pre-mixed concrete truck. It's about 10 yards. So that'd be two full yards, 2 full trucks of concrete to pour this thing. And besides the concrete, of course, there's steel and excavation and all kinds of other things that we're going to look at when we start looking at some videos, which is going to be really soon. And then I'm going to tell you another thing about the logistics of what we're doing here today, which I've kind of figured out. And that is that we have basically a 3-hour class. We're gonna take a break after each hour. Okay, so basically there'll be 2 breaks. And in the meantime, let's see if anybody else has joined us. Has anybody else come in? Let's see, D'Angelo, you came in. I didn't get you initially. Mr. Rangel, would you please let me see your video? Mr. Rangel, thank you very much. You're here. Okay, Kobe, you're still here. Did anybody else come in and not say present, hello, not be called by me? Looks like D'Angelo. And D'Angelo, what? I know I asked you last week. D, right? Yep. D. Okay, sorry, D. Like I got a new roster here, so I don't have my notes from last week on it. That's D. Joshua is Josh. Okay. Okay. All right. Options while you're here. 2 breaks. Zoom links, a good one. Figuring concrete by the yard. Okay. So I noticed that in talking to everyone or hearing, weird. Okay, there we go. So in hearing from everyone, I heard from a lot of you that are in the construction trade. Some of you that are interested in DIY stuff. Some of you just want to increase your knowledge about what's happening in construction, which is just it's a great reason to take this class. And then I heard a fair amount of you talk about getting the certificate. And those of you that don't know what the certificate is, the certificate is an AS degree. With your AS degree, you get a certificate from our construction academy that says you've completed and gotten an AS degree in the construction tech department. And it gives you one thing besides the certificate itself, which would be, you could go on to get a BA in construction management or wherever you wanted to go. It's good for a year and a half of certs for your California contractor's license. So if you don't know what I mean by that, I'll explain briefly. To get a California contractor's license, you have to prove or certify 10 years, you have to certify 4 years in 10 working as journeyman, super or above in the construction trades. And typically an employer has to certify that, or if you're doing smaller projects, an owner has to certify. There's various ways to certify, but there's a basic certification form that you have to have one or more than one certifying that you've been working in the trades for a total of 4 years in a 10-year period. Once you can certify that, then you're able to put forth the application, take the tests and do all that stuff. And an AS degree from City College and the construction tech department gives you a year and a half credit towards that cert. So then you only have to produce 2.5 more years within the 10-year period to certify that you are qualified, are you qualified to be a licensed contractor. I hold 2 licenses, California contractor's licenses. I hold one as a B1, general building contractor, and I hold one as a C6, which is a specialty license, which allows me to contract in the areas of cabinet making, millwork, and finished carpentry. All right, let's see, what are we gonna do here? Oh, I know what we're gonna do. We're gonna share screen. Okay, I gotta get rid of the floating meeting controls. So then I can get you to, okay, the first thing I wanna do is I wanna show you, now, are you guys seeing, are you seeing pictures?
Yeah, we're seeing your internet browser, seeing
Okay.
Zoom.
Good. So right now you should be seeing a picture of a Harley Davidson. Are you?
No,
You're not?
nope.
Oh, crap. Okay, that's fine. You're seeing my internet browser. Okay. All right. Let's see. Where do I gotta get this at? All right. What about? Okay, now you seeing my email?
Yeah,
Okay, good. You seeing a picture?
yep.
Okay. Everybody see that picture?
Yep.
Can anybody tell me what that picture is? Where is?
Looks like a retaining wall, maybe.
There you go. And that's the steel tied in the retaining wall with a CIP form on the left side and the dirt or bank we want to retain on the right. So it's going to be somewhat out of order because of the way it is. Let's see, that was that one. And then, okay, there's that one. Back. This one. So that's looking, we were looking down into that form on the other side of where that gentleman is standing on the staging. But that's a CIP, a site-built CIP, which is cast in place, or PIP, poured in place form for a retaining wall. The footer was dug and poured down below prior to the form and the wall itself, the footing was dug and rebar was put in the footing trench and rebar was stubbed up and tied into for the form. So let's go and see what else we got to see here. All right, there's a side view. This thing kicked off because there's a fair amount of pressure wanting to push that form board out. And all right, so this again, there's a form board, a 1 foot, 11.5-inch, 1 by 12 or 2 by 12 tall form. That below that, where my arrow is, that's going to be the top of the footing, and then you'll see more of this form. That's the outside form board. There will be an inside form board making a 6-inch stem wall. That it's not really a stem wall at all. I'm sorry. It's that actually top is the outside of the slab. So you'll see more as we do another picture here. And that's, oh, by the way, and those trenches are for the plumbing stubs for the single bathroom in this pour. That's the stub for the 4-inch for the water closet, and the closet flange goes right there. That's the vent for the water closet, or AKA toilet. And that's another vent for the shower. There's a shower box, goes underground, comes up, vents in the wall. And then there's another vent in the wall for, I'm not sure what that vent stack is for. I think that's a temporary vent stack, just to stack for the inspector, to show that that the vent is full of water and that all these joints hold water and they don't leak. Let's see. Oh, that's the one I thought. So could anybody tell me what kind of motorcycle that is? Yeah, it's a Harley Davidson. It's a 2004 Road Glide, and it's a Road Glide Ultra. The Ultra is the Ultra is made because of the fairings, tour pack, stuff like that. I just threw that in there. I had to show off. All right, so there's the outside form. Below the form is the footing. In this case, there is no stem wall because this is slab on grade. Slab on grade is poured monolithically, so the footing is poured with the slab. If this were getting a stem wall, you'd pour the footings first with the rebar stubbed up, and then they'd form and pour the stem wall. And that could be done monolithically too. But anyway, here's the yellow sand called out. These are dobies, these little pieces of broken off concrete with wire in them that you can wrap around and tie to your rebar. Those are called dobies. Those hold your rebar up off the bottom of the slab, which rests on this yellow sand, and keeps your rebar in the middle of the slab. And all these guys here that my arrow is pointing to with the blue tape around them, those are anchor bolts and HD hold downs, which are seismic hold downs, which will go against a framing member, usually bigger than a 2x4, like a 4x, that hold the building, strap the building down to the slab. All right, here it's being poured and screeded. I don't know if any of you know what a screed is. Does anybody want to chime in and tell me if they know what a screed is? No? Okay. So a screed is a large member, usually a 2x4 or 2x6, and it is usually it can be in a board in the middle, but it usually goes all the way across the form, and it's to screed the initial level of the pour, and then you finish it with finishing tools, with trowels, etc. But a screed basically screeds off any excess concrete and gets you to the level of the top of the form, which is where you want to be right here. Let's see. There it is poured. Let's see if there's one back. Okay, so these guys there's the screed. So they're screeding off the pour, just pulling it and try to get their initial level, which is flush with the top of the form board. Then they'll go back with trowels and darbies and long floats. You can see right up here in the corner, that's a darby trowel. That's a long float for getting the initial floating, the concrete smooth and level. Of course, if it's flush with the top of the forms have all been shot level, so they are level. And then you see a stem wall here, which we're calling a curb in this case because of the existing conditions for grade. I didn't want to take a chance that we would have any grade up against a wall that was wood framed. So you can have grade up against a concrete wall. And so I went ahead and came up 2 form boards to 2 feet and had the concrete guys put these 2 walls on a 2-foot high stem wall, which wasn't initially planned. But it's
Rodney,
gonna work out. It's gonna work out just fine.
are you putting any waterproofing on the back of that little stem wall?
All of that stem wall will be waterproofed. Yes. I'm gonna put in, before it's backfilled, I'll put in gravel and a French drain around it. And then I'll use some waterproofing system to waterproof it. So yes, and that's pretty much a must. This is a builder's level set up to shoot levels, which I demonstrated last week. Let's see if I got everything here. There's a pour, there's a wall. Now remember I told you when we laid out those plans that there was a discrepancy? And the discrepancy was that it showed this call out from this corner to this corner as 14 feet. But this wall here, 14 feet out from the plane of the building, is a continuation of an existing interior wall, which was 1310. Once the building was demoed and the stucco was taken off and that wall was exposed and pulled from the outside. So we had to fur out a wall in the house, which you'll see because I'm going to have some framing. I'm going to have some framing pictures, I think, next week of this this particular job. And here's a job in its formed stage prior to pouring. You can see, pieces of steel, short pieces of number 3 bar. And then, by the way, this should probably be on somebody's test. Rebar is designated by numbers, pretty much 3 through 8. There are bigger bars. I don't think there's anything smaller. I don't think there's a number 1 or a number 2 bar. It's possible there is. I just have never had a chance. I'm so sorry for all the yawning. But I'm cold too. I think I should close that door. Anyway, bars and numbers. So number 3 bar is 3/8. Number 4 bar is 4/8 or a 1/2 inch. Number 8 bar is 1 inch. So the numbers are in eighths. So number 5 bar is 5/8 of an inch in diameter. And you're going to see a job when I show the videos that I put together yesterday. You'll see a job with some number 8 bar in it. You'll see an unbelievable concrete job. So the thing about concrete, something to know about concrete, is concrete has awesome compressive strength. This way, compressive strength. And it has really very little tensile strength this way. So on a slab, almost no tensile strength. So that's what rebar is about. Rebar gives concrete tensile strength. Now, one thing I don't know if you saw when they were pouring those walls. Let's see. Okay. See if I got this picture. I hope I do. Shoot. Yeah, I don't think you see it here. I was going to show you a stinger. Yeah, nuts. Okay, I want to go the one back from that. So a stinger, having a heck of a time here. Okay. A stinger, who knows what a stinger is? Anybody? Nobody knows what a stinger is?
A stinger or a stringer?
Stinger, Stinger.
Like the stapler?
Is there a stapler called a stinger?
Yeah, they use it for Tyvek, the little with the green caps.
Oh, no kidding. I didn't know that. It's always good to know new stuff. No, a stinger is just kind of. Are you guys looking? You're looking at my email. Okay. A stinger is it's a vibrator that come in like all the way from 1/2 inch diameter up to 2 inch diameter. It's about a foot long, and it's on the end of a hose, actually a whip that can either be to a motor that's either run electrically with 110 or a gas powered motor, but it vibrates. The stinger vibrates, and it's meant to go down in a concrete pour, especially any kind of pour, but especially wall pours, and vibrate and shake that concrete and vibrate and vibrate and vibrate that concrete so it fills in around all of the rebar, fills in any spaces, nice and tight against the form boards, so that when the form boards are peeled, there's no honeycomb. And you'll see why that is so important really soon when we go to. Oh, okay. So I'm going to back up a second because I didn't do a safety meeting. I kind of got ahead of myself. We're going to do a safety meeting. Okay, I'll read the title, and I'll read the first paragraph, and then I'm going to call on people to read. So when I call on you, please unmute yourself and read. This is we're having a safety meeting for this class as per our regs, which is that we talk about safety every class we have, just like a job site safety meeting.
Can you zoom in, Rodney? Can you zoom in on that a little bit?
Say it again, please.
Can you zoom in a little bit?
On this one?
Yeah, on what we're reading.
How's that?
That's perfect right there for me.
Oh, I hope so. I got to zoom out a little bit so I can see it. Okay, can you read it okay?
Yeah, I can.
Are you on a phone?
No, I'm on a laptop.
Huh. Okay, but you can see it now.
Yeah, now I can.
Okay, good. So prevent injuries from falling objects. Objects falling from above and striking people below have caused serious industrial injuries and account for a number of fatalities every year. Although the exact number of falling object injuries is difficult to determine, documents produced in several recent court cases suggest that the practice of high stacking materials and supplies poses a serious safety threat to those below. How about Colby? Unmute yourself and read a paragraph, please.
Provide adequate warning. Workers or customers below depend on those working above for their safety. If you're going to be down working overhead, warn those in the area either verbally or with signs, ropes, or barricades. For those below, it's their responsibility to be aware of the work being done overhead and observe the warning and barricades.
How about Kevin Nolasco?
Secure the load. If you'll be lifting the load to a higher level, make sure the load is balanced and secured so it won't slip off. Restraints such as nylon strapping bands can be used to secure overhead goods. In some cases, merchandise to be stacked on top of racks can be shrink wrapped in plastic to provide stability and keep loose boxes and other items from falling. If using plastic wrap, remember that the plastic may stretch due to the high heat at the top of the racks and may cause the load to shift. Another safety precaution is to provide netting on stored items or restraining bars to keep the load in place. If you're placing a load on a scaffold or platform, make sure they are guard rails or tow boards to prevent material from falling off.
Catherine, could you read the next paragraph, please?
You bet. Moving a load, never lift, lower, or swing a load over anyone's head. Block off areas where loads are being lifted or lowered. Have a spotter in the adjoining aisle where items may be pushed off racks or platforms during moving or stacking of material. If possible, whoopsie, restrict these stacky and heavy moving operations to hours when fewer people are present.
All right, good work. How about Colby?
Practice goods housekeeping. Keep tools and other materials away from edges and off. Whoa,
Sorry.
it's okay. And off of railings or sills. Stack them on flat surface. Cross it
Cross tie.
if necessary. To keep them in place, if you're working overhead, watch that you don't kick, throw, or sweep material off that could fall on anyone below.
Why don't you go ahead and finish, please?
Okay. Whenever there's a risk of falling objects at a work site, an employer is required to provide protection for workers and visitors to the site.
Okay, any comments, questions, anything about that? Anybody? Anybody at all? Nobody? Nobody has a question about preventing injuries from falling objects? Has anybody been hurt or injured by a falling object? Nobody's had anything fall on them and hit them in the head? Boy, I have. I've had people knock stuff off. As a matter of fact, I was doing a job for Jim Messina, I don't know, 40 years ago, I guess, at least, maybe more. A spiral staircase in his house he had in Montecito, and I had a guy up there doing the handrail, and the handrail is parts that get joined together. So there's long straight runs, but then there's rake to plumb or rake to level goosenecks and up easings and all kinds of stuff. You have to join these stair parts together, and our stair part fell and hit Jimmy in the head, and it was a big deal. It was a bummer. It was. So please be careful. You can get hurt, and you can hurt people pretty easy. So let's go to modules.
One time I almost had a window fall on me.
Yeah, you almost had a window fall on you?
Yeah, but I caught it.
Wow. So from how many
No,
stories?
it was in the truck. We usually load the windows in the truck, and somebody didn't tie the window down properly. So when I was going into the truck to grab a tool for one of the guys, the window started to crease and almost fall on me.
Wow, frag. Good thing it didn't, right? Broken glass is nothing to sneeze at. It's gonna be really bad. So yesterday I called up a couple of concrete guys that I know, some pretty big concrete companies, big for around here, that's for sure. Matt Shaw, Shaw Concrete Construction, and KCI, Kenny Concrete Construction Inc. And I met Matt, and I went through this incredible job. On the beach, just. Okay, let's do the. Let's get the landscape up. Okay, we got Matt Shaw right here. Who's the president and CEO of Matt Shaw, Shaw Concrete Inc. Matt, can you tell us anything about this project?
Here's this project we're doing down at Carpinteria Sandyland Beach. We've constructed a house
You turned up a tiny bit.
on columns and a slab on grade garage. Total 75 case project.
Okay. So if you heard that, the garage is slab on grade, which we'll see. The rest of the house is raised quite a bit. It's at least 6 foot tall. It's on 75 columns. And those columns, those square columns, look like about 2 foot square columns coming out of the dirt, are sitting on caissons, which are full of steel. And their caissons are 24 inches in diameter. And there are holes in the ground that are bored 45 foot deep. filled with steel and concrete, creating the base for these columns that support the house.
5 feet deep and 67 columns to support this house above the water line at high tide.
Wow, so that was determined at high tide. So how do you determine how high to get it above the water line?
Basically, years past, floods and king tides, mostly the king tides and how much they came up. And so houses that being rebuilt are on either pilings or columns in case on this.
So does the water come, could the higher tide come rushing up or some tsunami will just come right under the house? Right? Is it breakaway foundation?
All breakaway walls.
Yeah, breakaway walls on the foundation.
All the walls are breakaway. Columns are all supported on that.
And so this is slab on grade with a garage curve, a little higher than normal garage.
Yeah.
Curve, right?
Yes.
The garage is access.
And we're protecting the concrete right now with drywall. So, yeah, so we don't get any, and this is the structural slab, so it's an 8-inch structural slab with a double mat of steel. And 12 inches of compacted material.
8 inches of slab with a double mat of steel. Holy crow. All right, and we'll see towards the end of the multiple videos I have here, you'll see that detail on the plans, but that garage slab is not just the 4-inch slab, it's an 8-inch slab. So it's two 4-inch slabs, and we'll see the detail on it, but it's just beyond belief. And that's 12 inches, and that's on top of 12 inches of a compacted material. Then the vapor barrier, or then a 4-inch slab, and then sand, and then a vapor barrier. Anyway, you'll see a detail later on, but it's everything about this concrete job is very impressive. And these load points, these guys were poured into it, right? These I-beams, or these columns,
They were set on either pier pads, and then gray beams would go through them, or they were poured on top of caissons.
Wow. Well, this isn't gonna have breakaway walls, is it? Or is it?
You know, it's gonna have after they frame it, then we're gonna veneer, a 4-inch veneer on top of the facade, all board form.
So a CIP veneer?
Yes.
4 inches of concrete?
Yeah, 4 inches cast in place, yeah.
This is super complex, dude. Isn't it?
Yes, very.
To say the least.
And that's my foreman, Salvador.
Hey, Sal. What's up, man? You're on YouTube now.
You remember Rodney, right?
This is a video from my city college class. Yeah, we're gonna be doing a lab on forming and foundations. And what do you? Pretty interesting forms, huh? And then that steel, you see anything different about that steel? Anybody want to unmute and tell me what you see about that steel that's different?
It's epoxy coated.
That's exactly right. Can you tell us why?
To resist corrosion, probably because they're close to the ocean.
Yeah, that kind of proximity to the ocean and that kind of proximity to that that close to the surface for potential for groundwater and king tides and flooding and all that jazz. The rebar, the stuff in the steel, you don't want it to corrode and go away because concrete is porous. So moisture does actually get through concrete. You want the rebar is all coated, which is like super expensive rebar. The tie wire is all plastic. It's not just a regular rusted steel wire. And you have to inspect this thing before you pour it. And if there's any nicks at all whatsoever, there's a paint. You got to paint any nicks in the painted coating for the rebar. You know, you guys are forming.
Yeah. Okay. This is gonna be. This is gonna be too. Look, I have all 4 foot, but it's too close. You want me to put in the center? No, it's not gonna be too. Look, it's more than 4 foot. You want me to move center both? This is too this way. I come to the center. 4. So this way you want me to put in the center here or what? What's that on?
There's a walkway. It's on. I'm seeing layout. These could be batter boards. Yeah, these are probably batter boards. These are your batters here, right? These are your batter boards for this run?
Yes.
With typical batter boards where you see how far beyond we are, right? Yeah, there's our batter boards. Let's get back here and take a look. Here's some stubs and sweeps for electrical. Here's our batter boards and some lines to be able to point straight to these footings and this poured concrete walkway, which slopes up on these footings. And goes all, I guess it goes all the way, I guess you could turn to left right there. Anyway, I'm gonna shut it down for a while and get some more information, okay? Okay, sorry about so loud background noise. Okay.
We're about an hour in, Rodney.
We are? Oh, thank you.
Yeah.
Cool. All right, so let's see. I will see if I can get my meeting controls back. I'm gonna remove the pin for now. All right, I'm gonna pin it back. I gotta get my meeting controls out of here so I can stop share. Hang on. I'll get them eventually. Shoot. Where'd it go? Come on, come on. Yeah, so, none of us are, well, I shouldn't say none of us. Some of you are probably super good on Zoom. I, on the other hand, am not. So where's my meeting controls? Damn it. Okay, there we go. Okay, so I'm gonna go back to grid video. Okay, so we're still recording. It's now, I got 7 minutes after 10. Come back at 10:20. Okay, I'm gonna stop recording and John's gonna help me remember to start recording again. Pause, stop recording. Okay. Did it. All right, cool. Okay, so we're back, and I don't know if I'm going to talk about PSIs and all procuring methods. I'm going to keep going on that, but yeah, we'll talk about PSI in the video. We talk about PSI, so we'll be able to address that at some point. So we're back, gang. Kevin and Colby, I want to see your faces, please. So I know you're here and not just hanging out doing nothing. You two, there you go. Okay, so I'm going to share screen again with you. Let's go back to course modules and let's go to Foundation 2. No, wait, Foundation 3, I mean. No, Foundation 2 or Foundation 3?
I think 2.
I think so too. Okay, so we're under the house. How's the volume? Anybody need it louder? Anybody need it louder? No? Okay, good, because it's really loud for me. I'm going to turn it down just slightly. Okay, here we go. Here on Sandyland Cove with the floor trusses in place, gang nailed, truss gang nailers, and then this whole thing. So Matt, this whole thing is going to get filled up then?
This whole bay, yes.
These whole bays, so it looks like about a 2-foot deep bay. Okay, so I'm going to chime in here for a minute. The that under the floor there, so it's a raised foundation, right? Yeah, those are floor trusses. So instead of floor joists, it's actually a truss system made up to make this floor, to support the floor and to give all that space under the floor. That space, which looks like about 2 foot tall to me, is going to get filled up with open cell foam. You might doubt it'll be closed cell. That's 200 pound. I'm pretty sure it'll be open cell, but it'll be Icynene. It'll be a blown in foam. It might as well be closed cell. It's very dense. It'll fill that up. That is a lot of insulation. It's an unbelievable amount of insulation. I can't imagine what the insulation is costing. I'll find out. And there's more as we get towards the ends of this trip. You'll find out a little bit more about what happens in this underfloor, and I find it super interesting. And I'll tell you when we get there.
It's all going to get filled up with closed cell foam or open cell foam, Icynene foam insulation, which is pretty darn efficient. Oh my gosh, this is unreal. 64 columns. The rebar is all coated. It has to be coated because of the proximity to the ocean, right? And the water table. So, and when they tie it, it's tied with plastic tie wire, and also if they carefully inspect it before they pour it. If there's any nicks, they paint the nicks out. 64 columns. And how many caissons? And 75 caissons, 45 feet deep.
45 feet.
What's the diameter of the caisson?
24 inch.
24-inch caissons, 45 foot deep. So these corners are headed out, and so
we're getting pop-outs right now for our hardware. So we have stainless steel 6x6 posts going in each.
And that's for the rail.
And then they'll set wood joists on top of that, and then they'll set their EP deck on top of that.
Oh, so this is all decking.
Yeah.
So this is just the
underneath
foundation for the decking.
Yeah. Foundation.
Wow. This is all. That whole walkway will be an Ipe walkway.
Ipe is a South American hardwood. It's one of those. It's one of the 50 million woods. It's called mahogany sometimes, but it's actually Ipe. It's a pretty dark brown, has some streaks of yellow, goes to red sometimes, but it's pretty uniformly brown. Very hard. It's hard on tools, but it's been kind of the deck material of the day for the last really 10 years. It lasts forever. It's almost as good as teak, but a lot less expensive. Ipe, I-P-E.
All the way up.
So Ipe walkway goes all the way around the house. I want to take a shot of a plan too before I leave, so we can talk about. Is this mechanical room?
Yeah, this is mechanical room. Mechanicals down below the house. They put drains in, so mechanicals you lift up a little bit, so if they do get a high tide, they'll be able to, the water will be able to go underneath the mechanical and then out the drain and then out to the street.
So these all daylight to the street?
Yes.
So you got enough fall, I guess.
Yeah.
Barely an inch.
Yeah, yeah. Hardly.
As long as it goes downhill.
Yeah.
So ideally, you want to carry all water on your site off the site to daylight, to a public street, storm drain, somewhere not to your neighbor's yard, off the site. And daylight is when you have a drain that exists in one spot and it heads out and daylights and comes out to daylight. It's buried and then comes out to daylight. And you need something for that. You need fall. So basically, you need to be able to go downhill. And so if you have a natural downhill, that's great. Sometimes you don't. Sometimes you have to create the fall in your trench. But ideally, you want a 1/4 inch to a foot, but you can do it in a 1/16 to a foot. As long as it's downhill at all, water will go downhill.
It doesn't look like you're gonna have, sure as hell don't have a 1/4 inch to a foot.
So like all these walls here, those walls have rebar in them, they're reinforced, so they're not going anywhere. But if you take like a wall, like this one right here, this would be a breakaway wall.
Which one?
Like this one right here, this would be a breakaway wall. So that wall, if they got a high enough tide, instead of interrupting the house, that concrete would just fall away and the columns would stay. They're not attached to the columns.
So they're just, okay, so no rebar ties them to the columns.
Yes.
And are they not, are they
They have
CMU?
rebar. they're poured in place concrete.
Okay.
Yeah, and they do have rebar dowels, probably every 32 inches.
So not a lot of tensile strength.
Yes.
Because concrete's high in compressive strength, but low in tensile strength.
Yes.
That's what rebar's about. Is this?
This is gonna be their septic.
So everybody's on septic here, San Juan? Yes, in the city sewer. I guess that makes some sense too. My gosh.
This is gonna be a fire pit right here. Just continue out and over here.
Eminently.
These are all exposed to form walls. So basically, we just leave the forms on, 2x8.
Yeah.
And form it, and not like this.
Yeah. Yeah, but formed 2x8 on purpose rather than sheets of plywood, so it would look more like almost like a wood wall, like a Wani hotel, right?
Exactly.
Which I'm telling you, you tell people, yeah, it's a concrete structure. They go, no, it's wood. I've been there. I've been right up to it.
Yeah.
It still looks like wood, but it ain't.
It isn't.
Wow, wow, wow. So they're waterproofing, what, up 4 feet?
Yeah.
On the wood frame?
Up 4 foot on the higher.
Ah, who drew this? I bet the inspector's having fun on this job. And then that, look at this. What's with this double wall condition here?
They got a slider door that
So that's
slides
it's
in.
a big pocket.
Big pocket.
So it's not double, but I see, okay, another pocket slider here with this.
Here, so this one will slide all the way through, and then this will all be put decking with these columns.
So these doors all pocket together. This is from this opening. They pocket into and disappear in this pocket. Open up, you walk out on this. Yeah, you know, some people got it pretty bad. But really, you know, with the concrete portion, now this is sample of pan deck?
So no, this is a sample of our pan deck.
Yeah,
So
yeah.
this is going to be where the jacuzzi goes.
Okay.
So we'll form this, and we'll put our rebar down, and then
So this
pour this up to a lower elevation.
In more commercial applications, in second and above stories, in buildings that have heavy duty foundations that are meant more for commercial and for multiple stories, you have concrete rather than wood floors. So I guess their second floor is going to be a concrete floor that's poured on a pan deck. So it's a welded steel pan deck, which you're seeing right there, and that's the form and doesn't get removed. But that's what holds, you know, anywhere from 4 to 6 and above of concrete for the floor. In this case, it's going to be for a jacuzzi pad, I guess.
It'll sit, so the top cover will sit down inside the deck.
Right, so you'll be able to sit on the deck, put your feet in, it'll be flush
right
to the
into
deck.
flush
So
to the deck.
it's really a sample, but it's also gonna get used for your
Yes.
jacuzzi, right?
Yes, exactly. Yeah.
And so is it a pan deck throughout? No, you got.
No.
Where's,
There's another pan deck up top
uh,
that they're gonna put,
what's the exterior?
the house.
Yeah.
Stucco and,
Glass and steel
it's glass and steel.
and concrete? And is this a planter? Is that what this is? What is this? A planter? So here's some existing EP deck. Little different.
We'll rebuild, so that deck that we saw over there.
Yeah.
that
It's gonna
will
come and connect
reconnect
to this?
To here.
Are they actually gonna leave this?
They're gonna redo all that.
I can't imagine putting
Yes.
this jazzy as this stuff is.
In the walkway.
Let's just walk out here to see where we're at. Yep, folks, this is where we're at. Sandyland Beach. Carpinteria, world's safest beach. This is gonna be the coolest looking pad around here, I'll tell you. So where'd you start out with? Did you start out with these CIP walls?
No, this came second or third. We started out with caissons, and then we started out with columns after that.
When did you start?
We started this about 8 months ago.
8 months ago. Was it competitively bid, or did he just choose you based on the stuff you've been doing?
Based on our high quality work, our design team, and our supervision over our projects, we've been pretty much exclusively bid for these bigger projects.
Yeah, he's got a great company, man. He's really something. I'm so impressed with that guy and his projects. And I guess this is just obvious how on top of it you got to be to even think you can build something like this. It's just unbelievable.
You have to trust yourself.
Oh man, and your supers and everybody, you gotta be able to step out, because for sure, I suspect, I could be wrong, but from where I'm coming from, that when you looked at these plans for the first time, you thought, oh my gosh, there was some stuff that was like, okay, how are we gonna do that, right?
Yeah.
But you can do it.
Yeah.
If it's concrete, you can do it.
Yeah.
If it's drawn,
yeah.
you can do it.
Yeah, you can figure it out.
Yeah.
There's a lot of coordination between me, my general manager, and our foremen, to come up with ways to minimize, time and labor and be effective in what we do.
Let's see your face for a second here so people can see who you are. Yeah, that's Matt Shaw. I knew it was him. It looked like the guy that held up my liquor store last week.
Not wearing my glasses.
This is incredible, man. So this is all CIP class, CIP or PIP, which is cast in place concrete or poured in place concrete. And as I've been telling you, concrete is super high in compressive strength and super low in tensile strength. So that's what rebar is all about. And this is special rebar because
this is a 4,000 psi mix.
And it's also important. So your standard concrete is 3,000 psi, right? Or 3,500?
2,500.
2,500, which is 5 stack mix, right?
5 stack mix.
And then this is a 4,000
Like
psi, with 7 stacks. And then we can talk about that. But Matt, can you just address that for a second? The difference between, say, a 5 stack and a 7 stack mix?
So a 5 stack mix is normally a 2,500 psi concrete. A lot of concretes have additives to it. So like when we poured our columns, we added a super plasticizer to the mix because there was so much rebar in the columns. And so what that super plasticizer does is it allows flowability. And so it was able to flow and flush out all the columns. And you can see there's no
honeycomb.
No voids, no cones, no nothing.
Yeah.
And so
But
with the amount
sure you had
rebar-
stingers for like multiple
yeah.
stingers, right?
Multiple stingers to vibrate and everything else.
And then Matt, could you just briefly describe a stinger for us?
So a stinger is a concrete vibrator, so it has a motor on the end of it, a plug, or there are gas-powered ones with backpacks, and they come with different size whips and different size heads, anywhere from a 1/2-inch head, which we would vibrate CMU or concrete masonry unit with, up to 1.5 or 2-inch, which you vibrate concrete footings with.
Right.
And
Or
3/4 your 1
retaining
inch.
walls.
Yeah, retaining walls. Big wide retaining walls. But retaining walls like this, we'd use a 3/4 or a 1-inch vibrator.
And it goes down into the wet concrete and it turns on and it vibrates and vibrates and vibrates and shakes and settles that concrete down into the forms and gets it outside of the forms and all around the rebar.
Yes, condenses everything.
Yeah. Because if you just poured that concrete in there and then
You would see a lot of. There's
but
notice those by the wall. There's no honeycomb.
yeah,
so
you have no
it's
honeycomb.
real vibrated really well.
Yeah.
And no pull joints.
Nope.
So.
Yeah,
But it takes a lot of coordination with
To do a continuous
trucks.
pour this size. I mean,
Yeah.
just this wall, how many yards?
On
is
this
wall?
job, well, this was with footing and everything, this was around 70 yards on this one. And one of our major tricks was the bridge coming over here is only a 20-ton bridge. So we either had to bring 3-yard loads across, or what we did is we set up a pump on the other side of the bridge and an empty truck on this side. and we pumped full loads into an empty truck, and the empty truck again didn't go to the pump and do that. And so
Dude, did you figure that out before you started?
Yes.
Did you figure, oh shit, we can't get, oh, I mean, oh heck, we can't get,
Yeah. Well, we knew we needed to find a way to get more, to be productive.
so you had to solve this problem right away.
Yes. Yeah.
And so you talked to, who's your pumper?
Albino Aguilera.
Was it, is it a big boom truck?
No.
Or just a regular?
We used a boom one time, and we found out that it was almost more work because we couldn't get a big enough boom across the bridge.
Yeah, yeah.
So we just basically had two pumps. We had one pump on the other side of the bridge. We pump a full truck into an empty truck. The empty truck would then come to the job site, unload into the second pump, and then go back out and get reloaded, 13 or 14 times.
Yeah, so for 70 yards, I mean, you're bringing what, 7 yards at a time?
We're bringing full loads, so we're bringing 10 yards.
Okay, so 10 yards
across the bridge.
So 7 trucks full.
And, yeah, and then.
And that's a continuous pour. That's 7 trucks not stopping. No cold joints, just keep going, right? Exactly. There's nothing like pouring concrete, and with some luck, I'll get you guys a film of Matt's guys pouring someday, because there's nothing like a concrete pour. Nothing like it, right? It is. And then when you're done, man, and the finishes are done, it's like you got something concrete. It's basically there
forever. And that's one of the reasons I chose the business that I'm in, is because I'll always live in Santa Barbara.
Yeah.
And I like to be proud. I'm proud of, I drive around and go by the Natural History Museum and see the whale and the concrete we did for them, and see these houses that we built, and see the structures, the commercial buildings that are built, and you take pride in that.
Yeah, and it's not just some work product that you made on a computer that maybe you want on paper, or maybe it was just some idea. This is something that's real in the universe, and that it'll be real in 10 years, in 20 years, in 200 years.
Exactly.
Although this one might, well, yeah, I might be. I'm opting for a new body the minute they come out. But, the proximity to the ocean means that the ocean might eventually take this away. But those columns right there they go down. So the bases of those columns, are the caissons underneath them?
Yes, caissons are underneath.
So they're 45 foot deep?
Yeah, caissons are 45 feet deep.
Those columns go 45 feet deep into the earth. That's insane, isn't it?
Yeah, so, and then they're 8 to 10 feet out of the ground. So
I mean,
that's about 55 feet supporting the house.
Yeah, in concrete. And laid out to a gnat's behind, too. You know what I mean? Because all these things have got to line up. If you look, if you were to take a string line and run a string line down that line of columns, they would all touch. You can see it from here. Same thing with these 4.
There's just a jog on that one.
Yeah,
right there.
yeah.
You can see all the way down.
Yeah, I know, and all this line. How much longer do you expect you guys will be here?
We have 2 more big planter walls that we got to do in the front. We have driveway. We're doing the ramp. So we're probably going to be off for about 2 months.
Yeah.
Let the framework and stuff,
Yeah.
stuff, and free up some space, and then we'll start doing more planter walls in the front of the house.
Kind of flat work, hardscape type stuff.
Those planters will actually abut to the house. They'll be an inch away. So once everything's framed and good to go, then we come in and we form our walls 1 inch away from the house.
When you're forming, like when you form these columns, like 8 feet out of the ground here.
We use steel forms.
Okay. Yeah. So they kind of clip together.
They just clip together, and the ease of taking them apart and putting them back together is tenfold in what form it is.
So they pay for themselves.
Yeah, so they pay for themselves. You do, I mean, you do pay a rental fee for those forms.
So you're not buying them, you don't have to store them, you're just renting them.
You're just
You have to diesel fuel them before you?
Yeah, we put form oil on them, so that way they strip easier.
Yeah.
And then put form oil on before we throw them back on the next column.
So you just snap them together. You just have to kick them off then, right?
They kick them off, yes. And they have kickers and they kick off to the top too. So you can keep them all in a line and keep them all plumb and square.
I feel like I'm at the World of Concrete. Which, by the way, is in Las Vegas every year, and it's worth going to if you've never been. It's really something. But just, they have just done so many cool things. They're like, everywhere. You don't have a place where plywood's touching concrete without it going over the DuPont plastic flashing. And then these are the footings for the Ipe.
For the Ipe deck.
And so these footings will get some sleepers in them that Ipe can nail to or something, right?
Get sleepers in them, yes.
And this is
it ramps. See, it ramps up that way, and then it kind of ramps down.
Yeah. It heads up, right? Does it step up here too?
I believe there is going to be
Looks like it might step right there.
Yeah, one step.
Is that your spider there? Yeah.
You can see all the tie wire is all plastic coated.
Yeah, see that tie wire? I'm zooming now. Tie wire, it's not just regular like metal tie wire, which is all rusty to begin with. This is plasticized, so there's nothing to rust in the form, nothing to corrode, right? Because we're so close to the ocean and we have so much moisture in the air and electrolysis and all that stuff, and if this rebar is just nicked, you guys go through and inspect it before it's poured, and they paint it. Is that number 5?
That's number 4 bar.
Okay, so all 4?
All number 4s.
What's the biggest bar you got?
The biggest bar we had was in our columns and our caissons, and those were 6 and 7 bars.
Yeah, so that's 3/4 and 7/8 diameter rebar, which is a pretty good size rebar. Yeah. Still just absolutely blown away. So when does this pour? You can pretty close.
Probably doing something next week.
Yeah, I might want to get out here for that pour. See that. In the meantime, beyond belief. So for now, we'll say goodbye. I'll fire you up and we'll get to something close. Goodbye, man.
Good luck, guys. And then in other places, as it moved away from the column, they spaced out to 6 inches on center. So.
How much longer do you expect you guys will be here?
We have 2.
Oh, shoot. Okay, remind me to tell you about what they're doing to the underside. I guess I must not have been on when I did that. Darn it.
And then in other places, as it moved away from the column, they spaced out to.
I had been filming with the record off. So I actually hadn't been filming the first part of these plans, but I think I go back through the plans and I think you get to see them. So here we go.
6 inches on center. So here's the connection from the caisson to the grade beam to the column, basically.
So all those square columns, they're all connected with grade beams, and underneath the columns are these 45-foot deep, 2-foot diameter caissons. A lot of concrete, a lot of structure to hold up.
57 minutes of battery. Yeah, now I got a full 32 megabyte stick in here because I checked it this morning. because this is invaluable stuff. This is the stuff I hope in my class will get a sense of, because really, this is kind of this concrete, this is a concrete sub-art, right? I mean, this is probably as complex
See, like here's
as
the
it
concrete
gets,
steps.
unless you're building a skyscraper, but really, there's not a whole lot of difference in some respects, other than skyscrapers are a lot taller. This is going to be the curve to your.
Yeah, those are
garage.
those are curb store garage.
Dang it. Grade being rather. And it has a shear schedule. So the James residence. I didn't think Jesse James's family did that well, but I guess they did.
Here's our frame. This is our frame.
So these clouded areas are areas where there were revisions or
Yes,
changes.
revisions or changes.
Right, so they're denoted, and it's a really great way to go. You know, those changes from a set of plans that perhaps the
Previous.
framer took off and did his bid on, and now we have a set that actually builds, so there's going to be some changes.
You can see,
right?
so all these beams, these are all our columns right here. These are all beams that run in between our columns to support the house.
So all these guys, columns, and then there's grade beams or beams above too.
There's grade beams below. So the
Tie all these guys together. So is this a continuous grade beam that ties all these columns together?
Yes.
Same thing here.
Yeah.
Get your finger out of there.
Well, this thing isn't gonna go anywhere. What, how many yards of concrete will this whole thing have ultimately in the end?
Ultimately around
800 yards of concrete.
about $80,000. I'd say close to $100,000 for concrete once you have the additives and everything else in there. And so here you go. This is, you can look, a lot of times your general foundation notes you can find on the foundation plan.
Yeah.
So 8-inch thick planter wall,
Yeah.
8-inch thick curb, breakaway, wood framed wall.
Yeah, so here's your planter wall.
And that would be the 8-inch thick leg wall.
And then this retaining wall on the curve, that should be at the garage.
I'll be right back, buddy.
Okay. And then
Here,
here,
thank you.
Oh, great, and Rip says hi as well.
Yeah, cool, man. To tell him, it's been a long time, but I'm super impressed by him and his stuff at this place. It's over the top.
Thanks, yeah, we're fired up.
Bet you are.
That's fun stuff.
Yeah. And Alex, you'll be immortalized with my class tomorrow morning.
Yeah, bring them on out.
Could we schedule a field trip?
Possibly, yeah.
I'll talk to you about it, because I'll find out, because I have to do 2 remotes. And then I can do, like, I have a hybrid, so I can do face-to-face, mask up, and I have a limited amount, so we could conceivably do it.
Yeah. We'll definitely try and make it happen, do our
Yeah,
best.
I appreciate that.
and see, so here's our details for our grade beam. So it's 24-inch wide by 24-inch deep, 10 number 5 bars for detail, number 4 ties at 6 inches on center.
Jesus Christ.
So,
That's a lot of steel.
yeah.
Number 5 bars, it's 5 inch
Yeah.
steel.
8-inch one-way slab.
What's it mean when it says one-way slab?
I don't know. That's one question I don't know, but it's top and bottom each way. So number 4 is at 12 inches on center each way, top and bottom. And then here's our shear schedule. So this is the way we figure out. We didn't have very many we didn't have any anchor bolts because everything's set up above. We had the templates.
Right.
Yeah. So the templates set
So
all the
really,
beams.
yes, because there's no,
We only have a little bit of hardware in
there's no
like this
plates
wall.
or anything going down on the foundation. It's all with on top of that, and then.
Yeah, exactly. And here's your caisson schedule right here.
45 foot deep.
45 feet deep, 24-inch diameter, 14 number 8 bars. Some had 14 number 6 bars, and some had 12 number 6.
Yeah, so those
number
are
4,
1 inch in diameter.
number 4 ties at 3 inches on center, and the lower reinforcement number 4 is at 12 inches on center. Here's our PSI strength. You can find that here. We poured everything with a 4,000 PSI.
Everything period.
Everything period.
Even slab on grade.
Yeah,
footage, the whole
everything.
attachment, right?
Yeah.
Yeah, why not overkill like you? Wrong, right? Nobody can call you on
Better
it.
to do a better project.
That's right, better project. Go the extra mile.
Exactly. Your client will love it.
Yeah, no kidding. And this is what the house. It's just, this is it. It's all on one plan, right? Is this
Yeah.
So this is the ocean, right?
Yes, that's the ocean.
There's that deck.
Yeah, the deck goes
And this
down
is that
the plane.
planter that we were.
It's the
where we
planter
were?
where we work, yes. So, you know, this deck's wrapping around now. Now it wraps around and goes all the way and
Right.
goes all the way to the beach, to the walkway. So,
Same elevation. Site, clear story, floor plan, building elevations 8301. Here's what this place is gonna look like from where we're standing, from the north, from.
So partial stucco, a lot of wood framing too. These are all
This is the
brick.
garage, right?
Yeah, yeah.
This is the garage,
Yeah,
the unit on top of the
yeah,
garage.
exactly.
You drive into the garage like that?
Yes. Here's the outdoor fireplace, all board formed, all the way up.
This is the north elevation, so this is facing this way.
Facing this way, so yeah.
So there's
we're
a fireplace
looking
out
at-
here
yeah,
too.
right out here.
But this is the ocean. This is the side that faces the earthquake. That's east. East or south. Here's the elevation that faces the ocean.
The pocket doors that we're talking about, so those all slide
Pocket
in.
together, these all pocket together, these all pocket in that pocket to make it completely open to the ocean. Oh my good gosh.
This is a ramp on our side that we're building right now.
Oh, this is that ramp?
Yeah.
That's that
Yeah.
self-same
So-
ramp?
yeah.
Okay, so they're just doing the footing for it
Yeah.
and then
And then they'll post up and frame out and everything.
Wow. But right now, that's that form that I shot earlier.
Yes. Here's another board form planner up the front.
This is the front.
Front east. So there's that deal over
So
there.
east elevation from you, so this is the
Yeah.
ocean, okay, right?
Ocean.
Looking at
Yes,
this.
we're pretty close, yes, exactly.
And this is garage.
Garage will be over here.
Oh, this is house. Wow, man. So really, Matt, it's not plaster. It's,
There's just,
it
I
looks
think,
like,
a small amount.
it looks like horizontal siding.
Yeah,
What's the siding on
I'm
there?
not sure.
Can we see, like maybe 2804 or some, one of these, any one of them will do it, 7A804? There's A804 right there. Okay. So 7, vertical siding corner. Lock miters, oh my gosh. Hey, class, remind me to tell you about lock miters. Thermary ash, TNG, blind nail. Hey, all wood. It's all wood. It's wood.
What's that phone?
All very, and then here's our detail for our chimney. So
On the man deck?
they're gonna put the chimney in first and frame it, and then we come in, we put a veneer on it.
Oh,
And veneer the whole chimney all the way down.
that's gonna be interesting for, so somewhat of an overhead floor.
Yeah,
Wow.
so we'll do it in lifts,
Mhm.
because that way it's only 4 inches of reveal, so you wanna make sure that you get concrete fully all the way.
Now, when you
down to the
say you
bottom.
do it in lifts, you'll do it in the
We'll
lift.
do,
and
we'll
then
do it, yeah,
vibrate it.
we'll actually probably just warm up to about here.
Okay, so it'll be
Pour
cold joint?
that, and then we'll cold joint it, stick our rebar out, and then in order to save the board form, we put tape and plastic on our existing pour
Right,
and leave our form ties in, and that
Right.
way we could leave our boards up
okay.
and then start stacking new boards on top of that.
So you won't know it's a cold joint.
No, you won't know.
See it.
No, it'll be right at the top of the board, and so
Yeah.
the next board will come down and flush right to it.
This is the deck railing. support Ipe with stainless cable 3/16 and the shape of the rail. Ooh, I want to do that. So these details, pretty significant details, I gotta tell you. Pretty significant in every way. So who is it? NMA?
Yeah, and they're out of Carpinteria.
God damn.
Newman, Mindro, and
Is it, what's his name, Newman? Is it
Newman.
Andy Newman?
Yeah,
Oh, yeah, these guys are incredible.
Mindro and Andrew Lucen.
Yeah, those guys are hot stuff when it comes to architecture. What we got here? Which one?
I think I was looking for the garage. Yeah,
Yeah, we can find it right here, but right. Details, I want to see that, A8, so they can see that. For building section, site plan. There's a perspective view of it. Site. All right, see, Rich Coffin. Are you on there as concrete guy? Wow. Too much, huh? Just too much. So, well, I've got this thing here, just for the grins, A8, let's look at. Four window and door details. Okay, there's some windows. Floor types. Total depth, carriage, floor type, structural floor truss. Oh, these are the trusses? Yeah. Oh my gosh. Structural concrete, roof types. Wall types, all these are various types of wall used in here, and then sections through, which are so hopeful. You're trying to do some.
They get shorter.
Say goodbye to Sandyland. This is the James project. Just wanting to see the last of it and how beautiful it is today here. And beautiful carpinteria and the wetlands. And what do we got here? A bunch of turkey buzzards. Wow, what a day, huh? The last of it. And just wanting to see this is the James.
Okay, so before I go to the next, they get shorter and shorter. We'll be done pretty soon. Next, I'll tell you about that after a while. So let's get through these. I'll tell you about the underside of this house, but not right this second. Let's go to 6.
Okay, I'm going to decide on Varley.
All right, so this is another site. This is a KCI site, Kenny Construction Inc. in Summerland. It's going to be slab on grade, but there are retaining walls involved and obviously CMU walls. So the footings have been poured. The plumbing stubs have been stubbed out and poured into the edges of the slab where the drains and vents are. And then they're getting ready to pour today, actually yesterday. I meant to come back for the pour, but I just didn't have enough time. Pour being to grout these walls. So here you go.
I don't know the street address in Varley and Summerland, but just showing you some I guess, grade beams. I think this is gonna be slab on grade, but these retaining walls are CMU, which is concrete masonry unit. They have steel in them. They're sitting on footings, foundations, and they at 2:30 today are gonna be grouted. And that means they're gonna be filled with concrete. I don't know what the PSA, I don't know if it's more than a 2,500, if it's a.
Anything over 4'8" tall in block walls has to have a clean out in the bottom. So those there are holes cut in this behind this form at the bottom, so that they can, if anything drops in down into those ungrouted cells of that CMU block, they can clean it out before they pour. So there's no detritus or dirt or chips or anything down in the bottom of that pour that would affect the integrity of the concrete. That's what that bottom piece of form board is at the bottom of the CMU.
Higher PSI, but that's going to be called for in the plans. And if I can get back here at 2:30, I will show you this thing being grouted and how the stingers work and all that jazz. So yeah, so this is going to be a slab on grade. They're going to be a slab on top of this, tied into this footing. There's apparently a drain or a drain of some sort. Looks like a toilet's going to go over there. Looks like maybe a little kitchen over there, or another bathroom. Hard to tell exactly. We got their staging up. Here's an example of another batter board that was obviously used to pull a line for this wall right there. And you can see another, Jim wanted me to mention batter, or wanted me to see if I can come up with an example of batter boards. There's another couple of batter boards that are set up beyond, so you can run string lines along the line of what you want to pour. Here's some more rebar. This doesn't have to be coated rebar, which is a lot more expensive. Even though it's in Summerland, it's still, and this I'm sure will get waterproof before it's backfilled. And here's the inside of the CMU cavity. So each cavity of the CMU has got two number 3 bars. And by the way, I'll talk to you about bar size as I hit this when we go over this tomorrow in our class. Okay, I hope I can get back here at 2:30, and then I hope I can explain more these clean outs. These are clean outs. I'm not sure exactly what that means, but these forms at the bottom, which will be pulled, I'm going to try to explain that clean out to you. Maybe this gentleman over here can explain it to me and I explain it to you. Okay, see you. Bye.
All right, one more. And then I went from there up to another, and actually this was a Matt Shaw pour. So this is Kenny.
Goleta. It's a Kenny construction job, KCI. And let's just take a look at this job, because it looks like they're just starting to dig for their foundation. There's some batter boards set up, job box, all kinds of stakes, looks like epoxies, and where are those anyway? Yeah, those are sprayers for form oil. It's for your forms to release. Backhoe, KCI backhoe, and a little skid steer. Footings being dug. More batter boards to be able to pull lines on right here. And an area drain. Yeah, big old area drain. Wow, that's quite the area drain. And then that's a whacker for compressing when compressing trenches that get backfilled. And this is there's another batter board back there. You can pull lines to. There's some lines hanging loose, and I think I'm going to call it this. And I'll try to get back to this job at some point so you can see the form boards up. Okay. Okay then. Excavation is happening right now for this job. They're excavating for the footings right now. Okay. Bye.
Okay. So we're gonna take a break. It's 7 after 11. Come back at 20 after 11, and then we'll finish up. Okay, see you at 20 after 11. I'm gonna stop recording, and John, you're gonna help me remember. Thank you. And let's see. Okay, ASL's back. Sorry about that. Hang on for me, kids. 1 second. Interesting call. My friend called me to talk about Pebble Beach at the end of March. Sounds good. So, okay. Hey, I just shared a bunch of videos with you. And actually there's one more video I didn't share. I'm not sure which one it is. So I'm gonna go to that, share it with you. It's very short. But let's see what it is. I gotta get you guys out of there. Foundation 7 back. Oh, okay. Oh, wait, did we see Foundation 7? I think we did. Yeah.
Okay, we're on a job on it.
Saw that. This is what we didn't see. So I was over near, this is just less than a minute.
I could not resist coming by the first house I ever built. I went and filmed that thing, the John Kinney excavation job, and then continued about a mile down to Spur Valley Road. We made this road, and this is the first house I ever built. I think it was probably about, I don't know, 1981, 1982 maybe. 2-story with a loft. Anyway, there it is.
Yeah, learned a lot on that house. It rained a whole heck of a lot that year. Okay, so here we are. Stop there, remove pin. So I should be pinned. Wait, I should be pinned. Let's see if I can get me you back on a pin here. Okay, I'll remove pin, and now I'll pin myself. All right. So a couple of things I wanted to tell you about, and then I want to save some time for any questions and discussing anything else. I don't know what Jim's got going on for you next week. I think he got somewhat into wall framing, so I pretty much can't go wrong because he's going to cover the whole book, or at least 7 through 12. So I think next week I'll have some shots. So we'll talk about framing and framing connections. We'll talk about floor framing, what there is of it. So I got to find a job that's got a floor like that one. I may go back and shoot that one a little more, the framing part, the one that's on the beach. That's definitely obviously a raised floor versus a slab on grade. And I can talk about framing connections and stuff based on my job. But I wanted to tell you a couple of things I made some notes about in watching those videos and then looking at the Chapter 9, Footings and Foundation, that Jim was going through. So one thing is that if you heard him talk about, if you heard Matt Shaw talk about pumping, some of you may not know what he's talking about. A lot of concrete is placed through a pump, and that's because chute poured or chute placed, that is the chute on the back of the concrete truck, the ready mix concrete truck, can only go out, I think, about 12, maybe 15 feet. Then you could wheelbarrow it from there and take it into your footing. But most people, if you're out past what you can back to and just shoot concrete into from the truck, you would shoot it into a concrete pump, and then the pump would go through, it's a 4-inch, very heavy duty hose, sections of hose coupled together to get to where your pour is, and then you're pumping concrete through a hose into your pour. And you can really direct the concrete a lot better than the chute, and you can get it long in places that you can't get the concrete truck. Concrete trucks are pretty big and pretty heavy. So So a lot of jobs are pumped, if not most jobs are pumped, because there's just not that many jobs you can drive a truck right to. And in Matt's job, he had the problem of getting over a 20-ton bridge, 3 yards of concrete, and the truck is 20 tons. So at 3 yards a shot for a 70-yard pour is going to make more like, you know, what, almost 20 some odd, 320, 23 runs of a 3-yard truck versus 7 runs of being able to pump from one side of the bridge into an empty concrete truck. That concrete truck rolls over to the site and it shoots into the second pump, which pumps into the foundation that you're pouring. So concrete pumps are part of almost every pour, especially these days. And besides being trailer mounted concrete pumps, which most are, that when I mentioned to Matt about a boom truck, there are trucks with these that are really big. And they have much bigger capacity for concrete. They can take something like 3 yards at a time. But they have a big boom that they extend out, and they can extend. I've seen boom trucks extend 100, 150 feet to pump overhead and then down to get over things, or over a house to pump into the backyard, something like that. Retardant is something there are a lot of additives that are available to concrete mixes, and concrete mixes is a whole other thing. A concrete mix, a mix design should be specified by your engineer. Concrete, basically your 5-sack off-the-shelf concrete is 2,500 PSI, and that's its compressive strength in pounds per square inch. And 5 sacks is based on 5 sacks of cement per yard. And by the way, for those of you who don't know, some of you do know, some of you don't know, since we're talking about concrete, concrete is not cement, right? Cement is what makes concrete. Cement, water, sand, and aggregate make concrete when it goes off. And concrete, once it's placed, and back it up to retardants, you would use a retardant in concrete if you were pouring in a very hot climate, or a hot climate, hot day, a lot of sun exposure, where that heat and that sun can make your concrete go off faster and make it less easy to work with. You would put a retarder in it to make the concrete go off and harden slower. There's powders to put in concrete to make it different colors. There's powders you throw on concrete that there's a color release after you put it on wet concrete. And there's stamps for concrete. There's all kinds of ways to do decorative concrete, but we're in foundations here. So, and foundations are also, besides footings, they're also slab on grade is considered part of the foundation. And slab on grade in any concrete needs to cure, right? So concrete cures, just to read a quote over here, basement floors, thermal insulation, slab on grade construction, sidewalk steps, entry platforms, placing the concrete. Where did I see that? Backfilling, code restrictions. Yeah, there's all kinds of stuff to know. Insulating block walls, laying concrete block. What was I talking about? I was talking about curing. There's some quote about concrete curing here. Anchors, blocks, removing forms, ordering concrete, aggregates, admixtures, slump time, cement. Anyway, the slower the concrete cures, the better, and the stronger ultimately the concrete is. And so there's a variety of ways to retard its curing. One is just to keep your slab wet. And that's pretty much what most of us do, is keep that slab wet. There are things you can put on. There's, okay, so here we go. Giving concrete tensile strength, and that's about rebar. And then, darn it. Okay, proper curing. Okay, so this is the quote I wanted to read you. Proper curing of concrete prevents loss of its moisture for a period of time. At 7 days, with moisture, it reaches 50% of its eventual strength after 7 days, 50%. After a month, that strength is double. So it takes about a month, and the strength of concrete refers to its compressive strength, not its tensile strength. So 28 days is about the time that concrete needs to cure to be 100%. 100% of its compressive strength. Concrete cures fast, moisture goes out fast, concrete cracks. And by the way, concrete cracks. You try to control that cracking with control joints, and a control joint is an on-purpose joint you put in a slab, and they can be put in at the time you pour the slab. You can score a control joint. They can be cut into a slab afterwards. They can be laid out and snapped out and cut. And control joints can be cut underneath walls that go down on slab on grade so that you don't see the cuts. But by cutting or putting in control joints in a slab, you are directing the cracking to go there. You said, okay, crack here. It doesn't always work that way, but that's the idea. Overhead pours. So again, like I said in the beginning of the class, of this class, concrete is used in foundations around here, Santa Barbara area. Basically two types. There's two types of concrete foundations. One is slab on grade, which you've seen the video of the Mangone job, that job of mine, and those pictures. That slab on grade, concrete's placed on grade, on the dirt, basically with with an underlayment of usually 4 inches of washed sand. There are various underlayments called out, and that'll be part of the plans and specifications, and that's usually part of having to do with soil, what's happening with the soil, how stable the soil is. But the other one is raised floor. That's where you pour footing trenches, you pour footing, and then out of that footing is a stem wall, like the curb walls, the 2-foot high curb walls you saw in the back bedroom on the Mangone job. Those stem walls are what you would hang the sill plate and the floor joists off of. And there's a variety of ways to do that. That's more into framing, floor framing, but that would be a floor that's up out of the ground, and you have to have from the bottom of the wooden floor joist 18 inches minimum of crawl space. There's all kinds of things that govern access, how much access, and also vents. All foundations need to be vented if they're raised. Foundation that's slab on grade doesn't need any vents because it's all concrete, solid concrete. Now overhead pours, there are overhead pours, and lots of them. For a variety of reasons, for floors, for garages, for multiple story floors, and generally in those, if you want a concrete pour, they're poured on a pan deck. So that's a welded steel, corrugated, usually pretty heavy gauge, like at least 18 gauge steel, and the corrugation gives it a lot of strength, and it's welded typically, and then the concrete's poured on top of that. It's placed in minimum 4 inch, could be 6 inch, and that creates an overhead concrete pour, and your pan deck stays, so you don't strip the form for that. There are overhead forms where you are formed and supported from below with wood, and then that's all stripped, and you just have the concrete looking up, but not in the case of a pan deck. You don't have that, and then I wanted to tell you a little bit about waterproofing of walls. Any wall that's going to be down below grade should be waterproofed. So, and most foundations should get some kind of drainage, like a gravel and a burlap of ground cloth wrapped around that, just around its foundation to tell water where to go with a slope, and a 6-inch perforated drain pipe laid in that gravel, covered with a burrito, to tell the burrito wrap is this black ground cloth wrapped around gravel. That's what we call a burrito wrap. And it's to tell water and give a place for water to go around your foundation and then out to daylight somewhere, ideally to daylight, which is where your downspout should go to. And then all walls, concrete walls that are below grade should be waterproofed on the positive side, not the negative side. And I'll explain that in a, like I say, a basement wall. So let's see, you got grade here, and you got a basement wall. It's down like that.
Professor, this is the interpreter. I can't see anything that you're doing on the board at all. Thank you.
How about now? Can you see that? I wonder if it's the red.
Yeah, that's much better. Thank you.
Okay, good. So it's footing, right? Slab, basement slab, right? So this is all below grade, and actually you're over X or over excavation on you know, virtually any pad when you're under undisturbed soil, you over excavate at least 2 feet. So you can get forming and people and equipment. And it's usually your excavation, if it's a deep one like this, like we're showing, let's say this is 4 feet deep, your excavation's at about a 45-degree angle. So less chance of cave in, and you can work back in there. But in something like this, if this were grade, this would say 8 inches below grade to the top of that wall, which is going to get a wood plate and then floor joists on top of that. Those floor joists could also be hung on a ledger. And there's a variety of ways to do that floor. But in the meantime, you'd want to get in there and put in gravel, and a pipe laying right there. Perforated pipe, 6-inch pipe with holes in the bottom, running all the way around to take water away from the foundation and out, and then waterproof this wall. There's a variety of products that would waterproof that wall, but you waterproof that wall all the way to just above where grade hits. And then when you backfill, you fill all that up, you've got things in place that take water away from your foundation, and any water that gets up to your foundation, it's not going to be able to get through because concrete's porous until you make it not porous. It's not going to get through, so it's going to go someplace else. And this is the positive side. This is the negative side. So if what happens is in a basement, for instance, or under, this could be under any house, under any raised floor, basement or a smaller space, if the waterproofing fails, or if there's no waterproofing and water starts getting in through these walls and collecting in here, your options usually aren't to go back and excavate and get to the positive side, because you may have sidewalks up against it. You may have all kinds of stuff going out, so you can't excavate. So people on the basement side, especially, there are products that you can put on the negative side to waterproof. Thorough Seal is one of them. It's not, that's Thorough Seal. It's not as effective as doing anything from the positive side, but there are negative side applications for waterproofing. And chasing water in basements is it's no fun. And in basements where you're, and in places where you do expect water, usually you put in some kind of a sump, put a pump in there with a float switch, so that when water fills that up, it pumps it up and out somewhere to daylight, away from the building. Yeah, we don't like water up against buildings, and we sure as heck don't want water in buildings at all. So questions, do we have any questions? I'm pinned, I'm gonna unpin myself. There's Katie. Go to gallery view. So, hey, any questions? Guys and gals, anybody have any questions for me?
I have a question about the French drain or the burrito wrap.
Fire away.
What kind of pipe do you use in there? I know there's gravel to be, put in there, but there's I've heard of two ways of doing that. I just want to hear how you do it.
Tell me the two ways you heard of.
So I've heard of that solid wide PVC pipe that has holes under, or just a strip of holes,
Mhm.
and then the one that's perforated. The black pipe that's got perforated a bunch of holes all over.
Okay, I like the white pipe with the holes in the bottom, personally. I don't, people use both, and I've seen both call out. Basically, if you've got a call out on the plans, use that call out. In other words, if the plans show you how they want to have your burrito wrap done, what kind of pipe they want, how much gravel, and where they want the ground cloth, that's what you want to follow. But if you're making it up as you go, I like the 6-inch pipe, the white pipe with the holes in the bottom, with the holes down.
Facing down, right?
Yeah, and there are people that say put them up so that the water goes in and then it carries off that way. I say put them down because any water that gets into that pipe from anywhere will let the water go out as it continues on down. As gravity does its thing, the water will leach down through the gravel and be dispersed in the soil.
Right.
And there are more than one school of thought about how to get water away from the building. But the one school of thought about water and buildings has to do with downspouts, because everybody's got a roof, and in Santa Barbara, you're mandated to have downspouts, gutters and downspouts, and all your roof water, you're supposed to capture it, and it's supposed to wind up going into hard pipe to daylight. So your gutters should have downspouts that come down and then tie into a hard pipe that goes down and then goes underground to daylight. And that's really what you want to do. And if you have a problem like I have on the Mangone project, I don't have the fall. I'm going to have to see how much. If I've got a little bit of fall, I'll make it go downhill. But I might have to go to a collection box, like a small dry well. And we can talk about that. And hopefully at some point we'll talk about how to drain a site, because it's pretty darn important.
Yep.
Any other questions? Questions, please. Preguntas más? Come on, I know you guys are just dying to ask me a question. I know Catherine is.
My question was, with the burrito wrap, you were talking about the materials actually that are in the burrito wrap.
Yeah,
So you've got your 6-inch pipe, just something that you like to use, and you said the holes downward. So how does that relate to the French drain?
It's similar to a French drain. I mean, if you look at the book, the book has a French drain, just pipe laying in gravel. The only thing that the burrito wrap does is you lay a black ground cloth. You fill that full of gravel and the pipe, and then you roll it all over so it's contained. That's what the burrito is all about.
Thank you. That really sets it up. Thank you. Mm-hmm. Okay, bye.
And there's more than one way as to waterproof. And if I don't know if we have a module on that, or maybe I'll come up with show you some waterproofing. But that black stuff that was on the Carpinteria job, that stuff is amazing. I can't remember the brand, but it's a little bit like Tyvek. It's an incredible waterproofing because it's sticky back, so it goes against material. Hang on one second. It goes against material, say concrete, and what it doesn't allow water or liquid to penetrate on this side, but on this side, it allows water vapor to leave. It's the same thing with Tyvek when you wrap a house. DuPont Tyvek has the same properties. It will keep, if you splash water on Tyvek, it will keep the water from coming into the building. But if your building is wet, if a wall is wet on the inside, the water vapor, the Tyvek will allow the vapor to off gas and come through the Tyvek. But it's tight enough weave, it won't allow a splash of water to come through, which is its beauty. All right. Anybody else? Any questions? Ordering concrete, placing concrete, CMU. How about that CMU, huh? So what do you think is more expensive? Slab on grade or raised foundation? Anybody? Anybody at all? Okay, nobody's gonna try to answer that? Okay, so, I'm sorry,
Maybe
I-
slab.
did you say slab on grade?
Yeah. Yes.
Okay, well, the two choices, is that Dennis?
Yes.
See, I can give Dennis, I can tease Dennis because I know him well enough, but of the two choices, you picked the wrong one, Dennis. Slab on grade now is about 13 bucks a square foot. When I was building, it was closer to 10. But it's right around 13, and that, because of course that doesn't take into account any special conditions or larger than, like the footings that we have on Mangone project, that because we didn't have a soils report, that are 30 inches deep. That slab on grade was I'm sure more than $13 a square, but a typical slab on grade, which has got a thickened edge, which doesn't necessarily have footings, $13 a square. And I think you're going to be closer to 20 bucks a square, but again, depends on a raised foundation. I said 20 bucks a square, but it's going to depend on how high your stem walls are and how big your footings are and what spans you have for your joists. And if you have mid-span girders and what your floor is too, because not only do you have to take into account the concrete, which is all you have to take into account for your slab, concrete and rebar, but on a raised floor, I've taken into account your concrete, rebar, waterproofing, and then your floor framing, your sill plates, ledgers, floor joists, and subfloor sheeting, which probably 3/4 TNG. All that makes up your floor versus just slab on grade, which is your floor. So you can see there's a little bit more to it. Personally, I prefer raised floors. For the money, it's well worth it to be able to run your utilities underneath your floor, hang things underneath your floor. It's just, I think it's a better way to build up off the ground, up out of grade. Yeah, you get your house up. So being down at the grade level for existing water conditions and flood conditions is less of a factor. And I like the springiness of a wood floor. There's a little bit of spring, a little bit of a give. It's a softer floor than concrete. There should be no give in concrete. If you feel give in concrete, then something's radically wrong. You shouldn't feel it. So there's a variety of reasons why I like a raised floor. And but it's drawn, architects are going to draw it one way or the other, and tracks, most tracks are generally drawn slab on grade, but not all, that's for sure. In the Midwest and back east, you have a whole lot of basements, have a whole lot of other building considerations, including frost and the depth of frost in the soil, things like that. CMU is pretty cool. CMU is used, that's concrete masonry unit. It's used to build walls. It's not used for flat work. It's used to build walls, short walls or long walls, tall walls. It's one way of building a wall, and it's a little cheaper and a little faster than CIP or PIP, which is cast in place, because you've got to do not only the footings, same thing that you have to do for the CMU, you have to do the footings, but you have to build the forms and then tile the steel and tie the forms together, and then pour solid and vibrate the forms. Of course, you have to vibrate or stinger the grout in the CMU wall, because all CMU walls, they're hollow block. If you looked at that page 209 of the book, you see, hollow block. All CMU, concrete masonry units, have hollow cells, and those cells are meant to house rebar and grout, and basically grout is concrete. And that's what gives the wall its incredible strength, because it's basically, you build a concrete form out of concrete that's hollow pieces of concrete, and then you fill it full of rebar and solid concrete. So eventually it becomes a solid wall. Now, another thing that I didn't tell you about is sometimes slabs. I had this thought when I was talking about Pandex and overhead pours. Sometimes you will get into a lightweight concrete to take some of the weight, because concrete is incredibly heavy. You can take some of the weight out of concrete by putting in a different kind of aggregate, some pieces of foam, vermiculite, or chopped up pieces of fiberglass. Concrete like that is called FRC, fiberglass reinforced concrete. So it's the fibers give it tensile strength, tie it all together, but because it's not rock and steel, you lose a lot of weight. So you can do light things. So we've done a lot of FRC molds that look like, solid columns, or, that should have weighed 500 pounds, but we can make them weigh 100 pounds because we used FRC. Okay, do we have any more preguntas más? Anybody about concrete or blocks or slabs, foundation walls at this point? Stuff we went through 9. I figured I'd get through as much of 9 as I could with y'all, and then we didn't get into steps. And I may shoot some steps because they're pretty cool things to form up. In concrete finishing, we didn't really talk about much. Estimating materials, we did talk about. So there's 27 cubic feet per cubic, or I'm sorry, 27 cubic feet per cubic yard. Concrete is figured by the yard, by the cubic yards. It's sold by the cubic yard in a premixed concrete. This talks about carpenter ants, which I don't think we have, but estimating materials, cement mason. And I guess Jim got into 10 with you too, right? He got into floor framing. So I'm not going to really touch on floor framing today, but I will next week. Next Saturday, I'll have some videos for you of real projects with real floors that are framed, and we can talk about that. We can talk about wood floors and framing details for floors and hold downs and sill plates and sole plates and HDs and Simpson connectors, because Simpson has the corner on connectors, and that's what we use, and that's pretty much what's called out. We don't use bridging, but we'll go through that stuff. And if any of you know anybody, Gemini's drop rosters are due tomorrow, or maybe even today, by the end of the day. Yeah, today by midnight. So we have to drop anybody that hasn't shown up. So none of you are going to get dropped. None of you that are listening to me right now, live, because you're here. Some of you, like about 7 of you, haven't shown up. And so if you know Dario Alonso, or I talked to Donna Davis, she's going to be okay. As a matter of fact, I'm going to give her an excused. Dalen Jackson, Eric Mendez, Eric Garcia. Eric, are you here? Because I know some of you. I'll call Eric. Edward Nolasco, Andrew Pacheco. If I've called any of your names, chime in, please, because I've got you as absent. Or D. Rangel. No, wait, I'll take it back. You're here, D. Jackson Rainey. If any of you are here, chime in. But if you know any of those people, you might want to call them, because they're going to get dropped. If they didn't attend last week's class or Jim's class, then they'll be dropped. And you can be reinstated if you get dropped. And if you get dropped by mistake, you can be reinstated. So, okay, this is your last chance. I know I keep looking at my watch to ask me questions. Anybody want to ask me any questions? Anybody at all?
I have a question. I just
Catherine,
was
fire
wondering,
away.
I was reading about Tyvek, and that's from DuPont.
Yes, ma'am.
Does Tyvek have the entire market? I mean, is there any materials?
It's a really good question. Catherine's brought up Tyvek, DuPont product. And do they have an entire market on house wrap and stucco wrap? And I think they probably do. There are other things. There are like Grace ultra waterproofing. There are more than one. There are more products than Tyvek to do waterproofing of structures. And Tyvek is used. Their most popular product is their house wrap their straight flash and their curved flash, or their flex wrap, straight flash, house wrap, stucco wrap. They've done such a great marketing job, and they have such a great product. They're pretty much called out, so they've become a standard in the industry. And yes, there are other products, but Tyvek is economical. They've got all the tape and all the nails for it, and you can pull up videos of how to do's. So it's the product of choice right now, but not.
I follow you. Also, I've seen it around the world as we've traveled. Sometimes it just amazes me. I guess it's sort of like Kleenex, that it just it's a brand name, correct?
Yeah,
But
it's becoming like that.
Okay.
Tyvek has become synonymous with house wrap when it's really like Kleenex. It's just another tissue.
Okay, thank
But
you.
it's a good one. You bet. You bet. Let's see. Anybody else? Anybody else?
Yeah,
That's right.
Rodney, so for my future DIY projects that we have planned, I'm assuming, because I hear you and the other teachers say here in Santa Barbara, so I'm assuming California doesn't have a standard code, right? Do I have to go through my city or through my county to find the codes that I need to follow?
Okay, that's another great question. So essentially, yes, your local county should have codes that will govern your project, but essentially we all use IBC now. And for the last 3 years, I think we've gone to IBC, which is the International Building Code. So all your city and county codes should conform to the International Building Code. And it should be the same throughout California. So it shouldn't be much different at all. Our codes here versus your codes there. You know, you have same soil conditions. You don't have permafrost, right? You have similar kinds of rain levels as us. So you're going to be the same as Santa Barbara. So IBC is going to govern you. But if there are any esoteric codes, any codes that are germane to your area, you'd be something to ask your building inspector or planning and safety at the building counter. You know, just go to, those guys have handouts forever about certain things. But if you're going to follow code, which is recommended, you want to follow our code, the IBC or International Building Code. We use that now throughout the United States, actually throughout the world. Used to be UBC, the Uniform Building Code, and now it's IBC, the International Building Code.
Yeah, because another reason what prompted me to ask you that was because we were looking at some property and we were thinking about buying it, but the problem was, Rodney, is it had a run through for water. And you know how you were talking about daylight? Well, the city over here wouldn't allow us to reroute that. They wanted us to keep it going through our yard, so it wasn't worth buying the property to put a house on, because the run was right to the middle.
Yeah. So it sounds like it wasn't feasible for you to build because the county doesn't want the owners of that property to redirect an existing water course, correct?
Yes.
Which sounds like a bunch of bureaucratic BS to me, but you know, obviously that they can tell you that, and then your next step is to see if they really can do that, right? In other words, the county, what is it? Tehachapi? Is that what's the county? San Bernardino?
Well, the county is San Bernardino.
Right.
The city is Hesperia.
Okay, right, Hesperia. But it was the county that told you couldn't do it.
Well, it was when we went to talk to them in the county office.
Okay, so those guys in the county office, county building, planning and safety, zoning, all those, they can tell you whatever they want. It may or may not be true. In other words, I'm not saying that it's not, it more than likely is, but it doesn't necessarily mean it absolutely is. And so were I you, I would ask around. I'd find an attorney if I really if I really wanted that property, and they said, no, you can't build it because you can't reroute this water course. I'd take it to the next level if I really wanted the property. Or you could just go, okay, fine. Because, you know, if it sounds like they've basically rendered it unbuildable, by saying you can't move this water course.
We're
Right?
talking about doing this, like,
Yeah, well, they just said that, that I couldn't reroute the water the way it flowed. But what I didn't understand is when I asked the guy the question, I said, how come it's okay for the elementary school to reroute the water, but it's not okay for me to reroute it?
Yeah.
And he had no answer. He had no answer for
like
me.
this, the French drain.
Yeah.
The only thing he told me was pretty much was, well, you can build over it.
Yeah.
We didn't know what it was called, but we wanted to do that even. Where you
Yeah.
put concrete on top and do like a French drain.
Yeah, and I wanted to do kind of, because what
We didn't know what it was called.
it was at the time I didn't know what it was called, but kind of like this French drain, is what we wanted to do.
And then put concrete on
Well,
top.
it sounds like you dodged a bullet on that one.
Yeah.
You know what I mean? In other words, an existing water course running through a buildable lot that was interfering with the building footprint that you wanted to put on it is probably
Yes.
not a good idea to put a lot there, because if it's an existing water course and it's got history, of decades of water going that way, and depending upon, the kind of rainy season we had, it could be a real nightmare for you. So they're looking out for you. You know what I mean? They're looking out in a broad sense. They're looking out for all of us. So you kind of have to take that into account. But the counties, in my opinion, county government can get high-handed, and they can insist on things that you don't sometimes are not right. In other words, I've been told by landmarks I couldn't build a particular wall or rebuild a particular wall over Mission Creek at St. Mary's Retreat House because they didn't like the color of it. They told me I had to color the concrete, even though it's abutting to a concrete colored wall. And I basically said, no, I'm not doing that. It's gonna be concrete colored. And then I did it. So
That makes sense.
it depends. But like I said, it sounds like you dodged a bullet. So
Yeah. Yeah.
that could be, because, that could be major problems. Unless you did do just what they suggested and had that stream run right under your house and have it be a whole feature of your house. I wouldn't do it.
Oh,
And if you notice, the really interesting thing and what's happening now in foundations around your school, there's a lot of new construction in Montecito around the homes that were lost in the fatal 2018 mudslide, right? 2018? Yeah, 2019 mudslide. We had a mudslide in Montecito that killed 22 people in January 6th of 2019. And a lot of the houses that are getting rebuilt higher, kind of like you saw at that house on the beach, with breakaway foundation walls below. So if they ever had another mudslide like that, they'd be sitting up on big, heavy columns up above the floodplain, and any of the rocks and water that washed away houses, in this case, would just break away and wash away breakaway walls and just wash under their house. And that's what they're doing. Now, none of this is cheap either, as you can imagine, right? Like, that house on the beach with those 65 columns, so it's $1.7 million worth of concrete. That's probably going to be a $10 million construction cost.
Wow.
If you were able to build that as slab on grade, if you were somewhere else and you wanted to build that house as slab on grade, that $1.7 million worth of concrete would probably wind up being like $100,000 of concrete.
Wow.
So you pay to build in areas where you have potential problems like water and flooding. And more, because we know more and more about it. We have more time to document these things and what happens, and measure the height of the flood and average that and all that stuff. And you've got a bunch of bureaucrats and bureaucracies that basically they maintain, their what they do by coming up with things to legislate about and keep you from building that property, which to protect you and to protect the public. That's what they're there for, right? They're public servants, right? Right? Right, is they? Yes, they serve us, right?
Supposed to be.
Right.
Don't get me started on politics, because we'll be here for hours, man.
Yeah, let's not start, because it could get ugly, and it would definitely start getting ugly with me. But I will tell you this, at the risk of fronting myself off, last Wednesday, the 20th, I felt like our country got its soul restored. And that's all I'm going to say. So what else? What else we got here? What do you got for me, guys? Anything? Anything about, does anybody want to go out and have a Saturday and like do nothing or have lunch? So what, if you could have anything you wanted right now for lunch, what would it be? Anything. D, what would you have for lunch if you could have anything you wanted right now? You could just, if you could just dream it and snap your fingers, what would it be?
You ever been to South Coast Deli? They got this chicken panini. It's pretty good.
Chicken panini?
Yeah, it's
Damn,
warm.
it makes my mouth water. All right, whatever. Josh, what would you get?
Chicken fettuccine alfredo.
Oh, baby, where would you get that? At Presto Pasta?
Either that or Olive Garden. I love
Okay,
it.
all right, okay, I'll buy that. I'll buy that. John, what about you?
I could go for a canned Capicola Club from Three Pickles.
Oh, God, that sounds so. Everybody's on a sandwich kick. Ugo, what about you? What would you eat right now if you could? Anything you want? You got to unmute, Katie.
I get a Chipotle burrito.
Thank you.
A Chipotle burrito. All this is sounding so good. Catherine, what about you? Anything you could possibly dream up for lunch? What's it going to be?
We have a Sylvester's burger up here in Pismo, and it's pretty killer. So I take
Celestial?
Sylvester's, and I put it with Ortega chilies on it.
Sounds so good.
I can tell where this is headed.
Okay, Jose Nunez, what about you?
Probably go with tri-tip sandwich.
Tri-tip sandwich?
Yeah,
Where would you get it from, or would you make it yourself?
I'd drive down to Pismo and go to Hoagie's.
How about you, Mundo? What about you? What's your dream lunch right now?
Some chicken Alfredo pasta. That's what I want.
Dang, man, that's two for that. Jose Landeros, what about you?
I'd probably pull out some of the tamales I have in my freezer and make some.
Oh man, this is okay. Okay, Eric, you made it, dude. You didn't tell me you made it. I gotta mark you here. Eric Mendez.
I was a little bit late.
Yeah. Anyway, I got you. Eric, if you could have anything you want, snap your fingers for lunch right now, what would it be?
I guess some birria tacos.
Birria tacos.
They're like really good.
What about lengua tacos? Taco de lengua. Ooh, baby. Okay.
Those are the ones.
Brenda, how about you?
I like soup and salad at Olive Garden.
Okay. That makes me want to drive to Ventura. Jesus, what about you?
The enchiladas my mother makes.
Oh man, what kind of enchiladas?
The green ones.
Green ones with what kind of meat?
Chicken.
Pollo, verde, enchiladas?
Yeah.
Delicioso. Colby, what about you?
I'd probably get some sushi. I don't know where from, but it sounds good.
Yeah, what kind?
I'm really adventurous, so whatever, honestly.
How about a dragon roll? Does that sound good?
Yeah, sounds good.
Let's get that. Okay. Aurelia, what do you want? What are you gonna have?
I'd get a frittata from Morel's right here in town.
A frittata?
Yep.
That sounds good too. Dennis, what about you?
I can always go for some tacos.
Tacos. What kind of tacos?
Al pastor tacos.
Al pastor. I love it, man. Kevin, what about you?
Try some In-N-Out.
In and out? That's good. Who can beat in and out? Okay, so for me, I'm going to admit that I'm strung out on McRib. I know it's bad, man. And thank God they come out and then they go away. And then I'm not, then I have to Jones for a couple of days and get the sweats. and then I'm okay again. But yeah, I'm strung out, and they put something addictive in those dang McRibs, man. I gotta have one right now. Okay, so that was a fun exercise. Next week, 9 o'clock, I'll see all of you here. And if you can't show up, please communicate with me either via email, text, or telephone. You should have all that in your, in my communication. This meeting is being recorded on Zoom, and it'll be embedded in there, so you can go back and do this class. I'll probably leave and let Zoom do its thing, and then I'll be back in a couple of days and I'll put it up. So it'll be up, and you'll see Jim Wednesday, and 9 to 12 is working for me. I hope it's working for you. So I'll see you guys next Saturday for our third lab at 9 o'clock. Okay.
Sounds good. We'll see you then.
Yeah. See you all then.
Thank you.
Great to see all your smiling
Thanks,
faces.
Rodney.
Even you, Dennis.
Yeah. You, Rodney.
All right, Katie, everybody's checking out. Joshua, Jose, you guys are in Hesperia. John Sesser. Well, that's it then. I'm going to say goodbye. John, see you soon. See you soon,
Yeah.
Jose. See you soon, Brenda.